if I'm live on YouTube. Huh, Okay, I think we are live. Ritesh is on chat. Okay, so YouTube is working and LinkedIn. I think LinkedIn is also working. Perfect. Cool. How are you, Aditya?
Hey, doing pretty good. Just a bit sick today, so please excuse me for that. But otherwise, fairly well. How about you?
Okay, yeah, I'm good as well. Do take care as the weather is not really good, right?
Yeah, we have London weather today here in Berlin. It's gray and cloudy.
Yeah, same. It's raining since morning. Cool. Okay, on chat we have Ritesh. Hi Ritesh. Hope you're good. Hello everyone. Welcome to our Sunday stream, Chine Cloud. In previous streams, we discussed about uh, our journeys, DevOps, and SRE. And today we are going to discuss something called platform engineering, which is like a yet another stream uh, or pattern of workflows which companies follow. We'll discuss. And if you have any questions, do let us know in the chat. Uh, yeah. Hello, Gaurav. Yeah.
Nice to see you here. Hey, but I'm going to introduce a plot twist today. So Suraj has been asking me a lot of questions and has been kind enough to host this. Today we wanted to give it a New Year's twist. So today I am going to be the host, and Suraj is going to answer and give us his knowledge about the platform engineering topics. How do you feel about that, Suraj?
Yeah. It's good to see the tables have turned in the stream. But yeah, I think we'll give like a 2 minutes so that people can join from whether LinkedIn or YouTube. Just wanted to ask, yeah, how was your first week of 2023 at office, at work, or even personally?
For me, it's been pretty interesting. I got back into work. I absolutely love working, so I was actually excited to get back to work after that break. So it has been great so far. There's a lot of initiatives that we are working on, and personally as well, have maintained my 7 day streak. I know Gaurav say here, so 7 day workout streak, still going strong with the New Year's resolution. Actually started in December, but going pretty good so far. How about you?
Yeah, same, pretty good. Like, I decided to learn something new, like, apart from the infrastructure bit, I decided to do more Golang stuff. So, I'm doing that. And also, like, I had my resolution, like, whatever content I produce, I'll be consistent at it. So, yeah, I'm just trying that out. And yeah, of course, like, the health as well.
Yeah, and
Looking after
now
the
we can
health.
see the stream is going viral. FBI has entered the chat on YouTube, which is pretty interesting. Welcome,
Yeah.
everybody's welcome here.
Hello, FBI. Okay. I think we should start. Yeah, sure. Go ahead.
Sure. So first of all, if you're new here, this is Chai and Cloud, hosted by Suraj with Suraj and Cloud. I'm going to let Suraj introduce himself later this time. So I am your host for today. I'm Aditya. I'm an engineering manager, specifically for SRE at Red Hat, currently based in Berlin, and have been working with Kubernetes and other topics for 6+ years now. Suraj, how about you and give us a quick introduction, and then we can jump into today's topic.
Yeah, sure. Hi everyone. I'm Suraj. I run this channel Suraj in Cloud where I post like cloud native stuff, and I work as a platform engineer at a company called RVU here in London, and it's been for 7 years I'm into the space of like a cloud and the Kubernetes stuff. Happy to share all the knowledge that I have. So yeah.
Yeah. So for I see some new people, including the FBI here, joining in for the first time. So I'm going to just give a quick recap. Giant Cloud is a casual chat for us where we discuss cloud native topics and perhaps go deep into some of the topics. So this is sort of part of an introductory series right now where we covered first DevOps, we covered our career journeys, we covered SRE, and now we are going to go into related topic to DevOps and SRE, which is this new trend, which is called platform engineering. Suraj happens to be working in platform engineering for a couple of years now, right? So let's hear it from Suraj. What is platform engineering? Why is platform engineering important? Let's start with that and start perhaps with your journey of how you entered this space of platform engineering.
Sure. So let's begin with like how I ended up here, and then we'll go into the what exactly is platform engineering and how it is different from other space, right? I'll share like couple of interesting blog posts as well, which like in detail explains what exactly platform engineering is. So few years back, to be precise, 2019, uh, I was at Red Hat and I was working on CLI tools, command line tools for the Kubernetes and OpenShift. And in that time frame, I was only working on building CLI tools, right? Like I didn't had any production grade experience. So I decided to gain more experience and I started applying for the similar roles where like this cloud infrastructure or something on those lines. And this position came across which said platform engineer. Now when I read the description, it said like you have to know these tools, and you will look after the cloud infrastructure, but at the same time you will build tools as well, and like you will do code as well. So it was like best of both world for me, in case where I wanted to keep doing what I'm doing, which was like a writing code and like building CLI tools and all those, but along with that I wanted to build a production experience as well, like how the Kubernetes run at a scale, or not just Kubernetes, what are other things which are there required in running a particular application, right? So that was the main inspiration for me to get into the platform engineering.
Which is pretty interesting. So, how did that go so far? Let's, before we jump into platform engineering, can you tell us a bit more about what you do right now, what your day to day job is?
Yeah, sure. So in my day to day job, what I do is there are couple of things, and I'll explain my work now, but when we will dive into the platform engineering detail, then audience will be able to relate. So my first one of the first job is to maintain the all the platforms that we have. For example, the Kubernetes is the core platform that we have. So maintain the platform, maintain as in look after it, upgrade it. If you want to extend a functionality, find a open source solution, or if there's no solution, write your own solution, right? So that's the one aspect of it. Then the second aspect of it is supporting our developers, right? Like the application developers, support them in deploying their application to the clusters. So basically developer support. And then the third pillar is developer experience, so like when they are deploying their stuff, to make their life easier. That's one of the primary goal as well. So it involves like multiple technologies, so you not only look after the infrastructure, but you do write the code. And yeah, so that's more about it. Hmm.
Pretty interesting. So, the audience must be thinking, like, hey, what is this thing, right? This is what we call our DevOps team, or this is what we call our SRE team. So, let's go a bit into like what platform engineering really is. Can you give us an overview of that?
So as in what you mentioned.
So a bunch of people must be wondering now, right? Because you're writing code, you're writing like doing some infrastructure stuff, and this is very commonly. this has a lot of overlap with what people say is a DevOps engineer or a site reliability engineer. So I would like to go a bit into now like the definition of platform engineering, right? So we can start with that, and then we can compare across other things in this scope.
Yeah, definitely. So, what I would like to do now is I'll share a blog post link. Okay, I shared it on YouTube and I'll share it on LinkedIn as well. So, this is one of the best blog posts I have came across, and there are some other as well. So, the official definition, not very official, but from various blog posts is, let's say, platform engineering is the discipline of designing and building toolchain and workflow that enable self-service capability for software engineering organization in cloud native era, right? That's one definition. Other definition could be a foundation of self-service API tools, service knowledge and support which are arranged as a internal product. Okay. And autonomous delivery team can make use of this platform to deliver their product and feature, right? And also if you look at that blog post, they mention it as a internal developer platform, right? So these are like various definitions of platform engineering. Now if we go into the one definition in bit depth, so first definition was saying that this engineering, we design and build tool chains and workflows, okay, similar to software engineering or similar to what you did in SRE. Like even SREs develop software, right? Like in last stream we discussed that SRE means like you treat infrastructure as a software engineering problem, right? So you also define your tool chain and workflow. But the next line which will make a difference between DevOps, SRE and this platform engineering is enabling self-service capability for software engineering organization as a internal developer platform, right?
Yeah.
So what that means is we as a platform engineer will build a developer platform for our teams, and they will leverage this platform to develop their applications. Yeah.
So is there a reason that this there's a lot of focus on self-service here, right?
Yeah.
So can you tell us a bit more about like what that self-service looks like and why we need self-service? Because we were well off in the past with, hey, ticket systems or whatever, you file a ticket and so on, right? What is the need of this self-service concept?
Yeah, sure. So to understand that, we have to go little back in time and compare it with DevOps. Okay. So we discussed about the DevOps in our second series, and we said that the whole purpose of DevOps is to fasten the delivery of the application or delivery of our features to the production, right? So the whole goal is to fast, and like there are keywords like bridging the gap between development and operation. But what happened with that approach was there were a lot of anti patterns. So again, I'll share a link in the chat. This website does show a lot of anti patterns that occurred with the DevOps. And like one of the approach of DevOps was, if you are building it, you have to run it, right? So with that, what start to happen was the developer has to learn everything. Like they are trying to write code as well, they are trying to deploy it as well. And what happened was instead of fasten the delivery, it was slowing down the delivery. Okay. And if you go to that website which I mentioned, it does show like a various models, which are like a anti pattern, right? And in some of the model, what happened was some person in the team who is like a senior most person, and he knows everything. So whatever he says, right, like that person says, we should do the infrastructure deployment in this way, so everyone will follow that. Or the junior most engineer will just hand over the infrastructure stuff to that person. Now what happened here was the main philosophy of DevOps is lost somewhere, right? Now there's one person who is taking the decision of infrastructure and deploying stuff, and it is taking time, right? It is not fasting. So if you look at those anti-types, anti DevOps thing, what happened was there were silos between dev and ops. Some team had three silos: dev team, ops team, and the DevOps team, right? Then there were another silos like dev with the DevOps and then the separate ops team. But that doesn't mean that DevOps model didn't work for everyone, right? It worked for big organization, okay, but it didn't work for smaller organization, and that's where the need of platform engineering came in, where there will be a dedicated team who will build a platform, and then this developer team will leverage that platform to build and deploy their stuff. Now why is the need, right? What's this platform we are talking about? In this platform we are uh, abstracting few things out. For example, let's take an example of Kubernetes. Now there is this big YAML you write to deploy the application, right? Now in this DevOps model, the developer will go to Kubernetes, what you call documentation, and then learn
Yep.
everything about Kubernetes and then write this manifest, right? Now as a platform engineer, being like, if the organization have a platform engineering team, what platform engineering team will do is will develop some tools which will abstract away all this YAML information. Like instead of writing it all, we'll say, hey developer, you have to write these four things and your application will be deployed. And that
Right.
way we are ensuring that whatever DevOps philosophies were defined earlier, we are we are proving that, okay, or I would say we are achieving those philosophies with this new model.
Yeah, so it sounds like we are abstracting away the infrastructure in a at a level that makes sense for the developers, right? For example, you don't now need to learn Kubernetes YAML files as a developer, so you can focus on your business logic.
Yeah,
So it pops up a couple of questions in my head. It's like, how much abstraction is too much abstraction, right? Like if you just give them a one click to deploy to production kind of a setup, do they lose flexibility in this case? Have you ever seen someone say, hey, we don't really like want to use that platform, we have a custom need, what are you going to do in that case?
definitely. And that's the that's the beauty of platform engineering as well. We we think that we are losing some capabilities when we look at one standardized project. So for example, uh, there's this project called K Compose, right? What it does is it takes your Docker Compose, it converts it to Kubernetes, right? Now you are very much bounded by that Docker Compose file, and the output is Kubernetes, right? Now that's a very generic open source project. But having a platform engineering team means you are doing abstraction specific to that company, specific to that developer team, specific to their needs. Like for example, in my organization, if we build some tool to abstract away something, right, we will make a prototype of that thing. We'll show it to developers, we'll say, hey, we built this, do you like it, do you need more inputs on it? So that way we keep that feedback loop ongoing as well, right? Like one of the anti pattern we saw was silo. So we try not to keep silo, and we demonstrate things like, hey, we made this, and that's about it. Now one of the great example here is, for example, defining a particular set of infrastructure. Right now, let's say a database. Now if you define database using Terraform, there are 1,000 parameters to define, right, which may not be relevant to a developer. So what we can do is we'll write a module which takes only 3 to 4 inputs, and rest of the inputs are defined, predefined, right? Now developer just has to say, this should be my name of the database, this should be my instance type, and this should be whether MySQL or Postgres, right? And that way they can uh, spin up their own database and do stuff. Now here, if you see the difference, by defining the module, we we made one a way of doing thing, right? So on that blog post, it's called pave road, right? We pave the road for them. Now they can leverage that and like self serve, like they don't need to come to us to define database. They can simply define the module themselves and use the database thing. Yeah.
Yeah, well, so that's a very good point, and I wanted to follow up on a specific topic. But before that, we are 20 minutes into the stream right now. I want to encourage people, if you have any questions, please put them in the chat. We can see them, and we will take them as we go. Right. So I will look at these questions and ask Suraj as we go. So, Suraj, one thing that I always think of about these platform or DevOps or whatever, right? This is a separation of concerns in terms of responsibilities, right? So, when we had Dev and we had Ops, Dev was responsible for development, Ops was responsible for operations, right? But then we go to SRE, there's like a combination of both teams responsible. Platform engineering, now you're saying there's a platform and Dev is responsible for operations. Like who's really responsible for what? Like what's the separation of concerns here? Sounds like platform team is responsible for platform and operations of the platform. Are we taking all the operational load for the services and giving them to the developers? Is that how it works?
So the first thing, we'll discuss about the platform and the SRE later on, right, in the stream. uh, Before that, what are the responsibilities that we have to understand, right? So if you go back to the blog post which I linked, there are few principles of the platform engineering, right? If we focus on that, so the first is clear mission and role. The second is treat your platform as a product, focus on common problem, and glue and don't reinvent the wheel, right? So let's go one by one. The one is clear mission and role, right? Example could be build reliable workflow that allow engineer to independently interact with our setup and self-serve the infrastructure, right? So that's our mission statement. For an example, right? So let's take an example of small organization where they have a uh, infrastructure in Kubernetes and in AWS, for example, right? So, as a platform engineer, we'll define some workflows and some tools. Now, those can be a team who wants to define a namespace, right? Now, it's not as easy as you just do kubectl create namespace, right? There are so many things comes with the namespace. Monitoring for that namespace, some sort of RBAC rules for that namespace, predefining uh, some sort of service account in that namespace, right? Now all those things, what as a platform engineer, what we do is we define a system, a workflow where if someone wants to create a namespace, they go to a particular rep, they raise a pull request, and that workflow will automatically set up a namespace for them, right? Now, if some team wants to define a database, we made a workflow, we maintain that workflow, which will automatically create all the required security groups, all the various aspects of it, right? Basically, we are taking away that responsibility from them, and we are building that whole workflow and that software tool chain, and we are maintaining it, right? So that they can independently interact, as in they don't need to raise a ticket saying, hey, I want database, or hey, I want to create a namespace. No. They can just go to a repo, raise a pull request, or in some cases they'll have some sort of a UI where they'll go and just click click click, and the stuff is ready for them, right? So that's more about the first bit. Now the second bit is treat your platform as a product, right? Now, as a platform engineering, when you look at your platform, now that can be AWS, Kubernetes, whatever you offer to your developer, we treat it as a product, and we offer that product to our developer, and we continuously advocate as well. For example, if there's a company who is selling something, they'll keep on advo- uh, you know advertising their product. Similarly, we do the same thing. uh, we make a proper documentation around it. We keep talking about it. If there are any internal showcases, we keep showing, hey, we built this, and I think this can be a useful for you, right? Now a great example for that can be, I'll show you one of the project that we built. Let me put it in the chat. Now there's this project called Hermod. Okay. Now, as a platform engineer, why we thought of having this project, right? So there was a problem where we were moving away from one sort of CI system to another sort of CI system, and with that, our developer wanted to know that, okay, something is wrong with my Kubernetes deployment. What's wrong, right? Or when I'm deploying something, I need to know that I'm deploying. If it is failing, why it is failing, and if it is passing, then everything needs to know, right? So we built this tool.
Yep.
uh, before that the problem was either they used to look at CI, or as I mentioned before, we provide support to developer. They'll come to our team and say, hey, this is my application, I don't know why it's failing, but it is failing, what should I do, right? Now, to convert this use case into something self-serving, we build this tool where now what happens is, as soon as they push deployment, their Slack channel will get an alert, okay, that you have deployed something. uh, if it is passed, it will show, this has passed now. And if it is fail, now if you see, there are some screenshots in the readme. If it is failing, it will show that this has failed because of this reason, right? Now, this is some sort of self serve thing, or they can independently look at the thing and they can fix themselves. They are not depend on any ticketing system. They are not waiting on someone else. Quickly they are looking at the system and making their own decision, right? And that's our product. And not every team is using it, but we are keep advocating, like, you should use this, so that you can make your software more reliable, for example, right?
Yeah, one of the things that comes to mind is, so as we are going into this domain of platform engineering, what's going to happen is a lot of companies are going to come up and they are going to say, here's our internal developer platform. We developed it for our niche use case and it fits our use cases perfectly. What are some of the opportunities, or what are some of the projects that are trying to like make this an ecosystem, right? Where, for example, this tool that you develop, how can someone listening to this recording start using it? Or like, is there any initiatives that are looking at the broader ecosystem of platform engineering and saying, here's a base platform, you build plugins on top, and then we can like share it across companies?
Definitely, definitely. uh before answering to that, I'd like to mention few things, right? Every company has a very unique requirements, or their developers will have a very unique requirement. For example, my team is using some XCI system, some other team will use some Y system, right? So every company has very unique requirement, or their problems are different based on their technical stack, or something like that, right? Now, there are options, right? For example, I would like to highlight here a project called Spotify Backstage, right? So I'll link it in the chat. So Spotify Backstage is something very similar. It is developed at Spotify, and it did start as a developer portal, or you can say internal developer platform, right? But eventually what happened was, they thought like, whatever we have developed here, it can be used by other teams as well, so they open sourced it, right? And what they did with Backstage was, they made a plugin system with it, so that you can you can write the plugin and you can build your functionality within the platform, right? So that's one way to look at it. But there are other startups as well who are offering a internal developer platform, uh, based on their experience, right? Now, again, as I said, every team has a different way of looking at it, right? So yeah, the backstage is very good example of it, I would say.
Yeah, I quite like Backstage. It's we have a
Yeah,
similar platform internally as well. I quite like the UI aspect of Backstage and the plugin model where you can take this UI that's a general UI, you can plug something in and at your company, I'm seeing a lot of companies adopt this as their primary internal developer platform, right? So that's a one good project, I would say, in the open source ecosystem where people are contributing to. The other things that come to mind are things like Crossplane or whatever, right? They are also like they're not necessarily a developer platform, but they have this concept of self-service where you can deploy it to your namespace, and within your Kubernetes object, you can define, hey, give me a database, and you just magically get a database. So yeah, pretty good, interesting projects. We are working on some as well. I'm not sure how much of it is already published, so wait for the other things. But
yeah,
yeah, it's pretty good.
yeah.
Uh,
And definitely, yeah, go
Go
ahead,
ahead,
sir.
go ahead.
Yeah, and one more thing which is very important when it comes to platform engineering is again the blog post. I'm referring to that blog post, which is don't reinvent the wheel. So what happens is when you have a 10 different developer team, right? There's a very high chance that one or two teams will come up with their own way of doing things, right? And this is what happens at bigger companies as well, right? You will often see that two teams inside the same company are using two different things, right? And then the third team, tomorrow third new team comes and they write their own thing. So the key thing here is don't reinvent the wheel. uh, Gather the requirement and build one solution which works for that particular company, right? And that's one of the principle of platform engineering. For example, uh, if a team, like in our case, for example, a team wanted to do something with the CI, other team wanted to do something with CI, and we have a third CI solution. So what we did, we took a poll, right? And then we did a POC around various tools, and then we decided that okay, we should go with this particular solution. As a platform engineering, we will look after it, and we'll offer this as a product to our team, right? But another one thing to mention here is we are offering our tools as a product to other teams. That doesn't mean that we will code for them, right? They are responsible for their code, we are responsible for our code. So yeah.
When you say it's a product, do you do some sort of chargeback or cost attribution as well? For example, if you're providing a platform, right? And then let's say you decide to introduce a SaaS. So you get a CI from a different vendor. You provide that as part of your platform to these teams with a tenancy model, presumably. How do you do like cost attribution? Or let's say you start providing a metrics platform and someone like is a noisy neighbor. How do you do attribution to that? Like, has that ever been a problem for you?
Definitely, and that is something we are currently looking into as well. And the chargeback, the philosophy of charging back, we are definitely introducing, because the thing is, as a platform, as a team who looks after the platform, uh, company will look at you as a cost center, right? Because you are not really delivering, right? For example, you are a company who does a train booking, or let's go back to our pizza system, right? The company who does the pizza, right? Now, as a platform engineer, you're just looking after cloud, you are not selling the pizza, right? So company will say you are our cost center, you are just spending the money, but you're not doing anything. But the real fact is we are the core of it, right? If there is no platform, where you will run your store and how will you sell it, right? And as you mentioned, charging back to particular team is really important. And the reason for that is, for example, if we go back to that pizza shop, right? Now in pizza shop there are three teams: one who sells pizza, one who sells garlic bread, and one who sells chocolava cake, for example, right? Now, how do we know that how much revenue this individual team is getting, right? Now you will say, okay, I'll just see how much pizza they sold, how much chocolava cake they sold, but at the same time, how much infrastructure they leverage, right? And that's where the chargeback module that you mentioned comes in. For example, the pizza team used $1,000 on the R platform, and they generated $2,000, right? Or a chocolava cake, they used $500 of our cloud infrastructure, but they only got 300 in revenue, right?
Yeah.
So, and how to do that? So there are various tools which helps you to achieve that. Now one of the example which I am looking into is recently is called cube cost. Now cube cost, yes, cube cost, and with cube cost you can you can go further granular inside your platform and understand the cost of each and every resource, and then you can charge back to the team saying, hey, you are using my platform, right, as in like a product. Now we said that treat platform as a product. For example, you're using my Prometheus, you're using my Prometheus stack for this much money, right? Give me back that money, right? Like not literally getting the check, but in some other form, right? So definitely there's there. And the chargeback which you mentioned, I think it falls under this new buzzword called FinOps. uh, with
Yeah.
this cube cost and other tools. So I think we'll have a separate FinOps session.
We need to get
Oh,
someone who's an expert on FinOps, right?
yeah,
So
yeah, yeah. Mm,
I believe Ritesh has a very good question about this, right? So can we consider platform engineering as a menu card for the developer? So he or she can order from the menu. Is this like a menu card where you can order some stuff? It sounds like a service catalog thing.
Uh, I would say service catalog is one aspect of it, but again, that varies from company to company. For example, here, what we do is like we build our tools and we say, hey, we have this. And it's not like menu card, right? Like the hotel will not say you go for this, right? It's like a proper sales pitch. Like we build this and you should use this because it's gonna help you, right? So the menu card analogy goes more with the service catalog, I would say, which goes with things like you go to a UI and you say, I want to deploy Java, or I want to deploy Go application. That kind of functionality is there in the Spotify backstage kind of platforms where you can define things and do more of it. But I think some aspect of it can relate to that thing which
Yeah,
Ritesh mentioned.
I do think that that's an important aspect of self-service in the platform engineering model, where you provide a list of services and you provide a menu or sort of a catalog of what you're offering, right? So there's your catalog and there's the alternative options that people have, right? For example, if you're providing a CI, that's on your menu card, and a customer, let's say a hotel example, going back to the hotel example, you can choose to order room service and it will be the best because they know exactly where your room is and they know what your situation is and so on. So there's the hotel menu card, and then you can also choose to order takeout from one of the random takeout providers, right? And those takeout providers will also provide you a similar service. Perhaps they don't have the internal know-how or internal services. They wouldn't have sort of a person that brings it to your room or whatever, right? So there's trade-offs both ways. Maybe you want something that's not on the menu and you can order from somewhere else, and like you win. In the end, the purpose here is to feed your hunger in this case, or in the technology sense, you have a need. Let's say you need a database, or you need, for example, no SQL database, and Suraj's platform team only offers you a SQL database, right? So you have two options. You can either go talk to Suraj. Ideally, you go talk to Suraj and say, hey, can you offer a NoSQL database as part of the platform? And if he says no, don't have time, or like not a priority, not enough people demanding it, you go with a different one, right? You are always flexible. The purpose here is not to provide like one menu that you must adhere to, but I do think that it's an aspect of it.
Yeah, yeah. And one more example from my work I can give is a very good example I like to mention is the ingress, right? Now, in our case, we have multiple ingresses available, right? And user is free to choose whichever ingress they want as per their need, right? Now, again, it's like a catalog. There are four types of ingress. We made sure that there's enough documentation around it. Now it's developers or user responsibility to pick the ingress and use it, right? Now all the operational complexity of having these four ingress classes, we took care of it, right? We abstracted away all those things because uh, maybe some team will be able to deploy their ingress controller, but because they also want to focus on their application delivery, they may not focus on the security aspect of it, or they may not focus on certain aspect of it. But because it's our primary responsibility, we'll take care of it, like with the better standards, say. Yeah.
Absolutely. And the other thing I wanted to ask, so shifting topics a bit, right? I have three specific questions that I'm going to ask, and we are 40 minutes in, so we can try to keep those brief. So you mentioned this responsibility of the platform engineering team being towards the platform, right? And I wanted to relate that to what we have previously discussed. And I know that your organization, for example, has a platform team and an SRE team.
Yeah.
How does that relationship work, and what is the role of the SRE team versus your team, right? What is the differences over there?
Yeah, definitely. So, as we discussed in the last session about the SRE, the goal of the SRE is to again treat a infra problem as a software. But more than that, the main core aspect is to keep things reliable, right? Using various technologies, like using maybe monitoring stack or maybe using something else. So, in our case, for example, we sit at the center as a platform engineer. We develop the platform. Now that platform will also have the monitoring element to it, right? We'll take care of the monitoring element. Then SRE team will also be consumer or of our platform. They leverage our platform, and then they will build their own tooling which will focus on the SRE aspects of it. Now that can be incident management. Now that can be making that can be looking after these three things which we discussed, which is SLI, SLOs, and SLAs, right? So I look at it that way, like SRE as a consumer of our platform, and leveraging the platform, and then build their own tooling and follow their own principles.
Yeah, and I wanted to add specifically on this topic that platform and SRE always work in very close collaboration,
Yeah,
right? Many times, for example, my team, we are doing platform and SRE, right?
yeah,
Both of it. We
yeah,
do platform development and we also do service reliability. So the way I see it is also separation of concerns, where you can now logically separate these two aspects and say there is a team that's taking care of standardization and building golden paths for people to use, and that can be consumed by the service team that's focused on reliability, right? So what you can then say is SRE is in an embedded model with the service teams, and they have deeper knowledge about the service. So what they are going to look at is not just the platform. They are going to consume the platform. They are going to take monitoring, CI/CD, whatever they need, so that they don't have to build it.
yeah,
And then they are going to focus on the reliability. So they are going to focus on SLIs, SLAs, and SLOs, and try to make not just the infrastructure changes, but also the service changes required to make the service more reliable, right? For example,
right,
focusing specifically on service architecture and saying, hey, this is the service bottleneck, or this is the key areas where we are burning the aero budget. How can we make this component more reliable? How do we rearrange the service in a way that it makes sense and scales well? So that's an important aspect for me, and that's a great collaboration actually. Which brings me to my second question. We saw what the SREs need in terms of a skill set, right? So development and operation skills. How is that different from platform engineers? What skill sets do you look for in a platform engineer? Let's say I want to become a platform engineer, or someone in the audience wants to become a platform engineer. What are the key skill sets you would say to get into this domain of platform engineering?
Uh, that's a very good question, and I think again, I'd like to say it does vary from company to company, and there is a, as you mentioned, like we SRE and platform does work hand in hand, and in some companies, a team called SRE will take care of both SRE and platform. In some companies, a team called platform will do both the things, or some companies will have individual platform and SRE, and some companies will have a dedicated platform team, right? I'll talk about that first, and then I'll come to the skill set, right? So that will give more visibility. Now, some big companies, what they do is they have a one giant umbrella of platform engineering, and under that they have a smaller teams, right? For example, there will be a team called compute platform, right? Now that particular team will only look after the compute. Now that can be EC2, that can be EC2 auto scaling, that can be their Kubernetes clusters, that can be their AWS Lambda kind of thing, like a serverless platform, right? Anything to do with compute. Now again, if you take any concept, that can be vast. Now if someone works for that team, really needs to have a very strong knowledge of compute platform and technologies around it, right? Now if you take AWS in case, right? So you need to know EC2, you need to know let's say a Kubernetes cluster, again depend on company, and then the aspects around it, like the security groups, all the volumes, should I use EBS or EFS, all these kind of thing, along with the programming aspect of it. For example, you need to know Terraform, which is like an infrastructure as a code thing, or you need to know some sort of programming language where you can build a system to provision the compute effectively, right? Now there can be another platform called, what's it called, when I was going through the LinkedIn there, I think Spotify had I am platform, or a identity platform. Now that team will only focus on RBAC kind of stuff, or like a I am identity kind of stuff. Then there is data platform. Now that team will only focus on data pipeline softwares, like for example Argo workflows, right? It's an open source orchestrator for like a data pipelines. Now that team needs to be expert at Argo workflows, right? And not just Argo workflows, the relative relevant tools, like for example this very famous tool in the space called, what's it called, Airflow. I think Apache Airflow.
Yep.
Yeah, these kind of tools, and like in that space people mostly use Python, right? So you need to know Python, right? uh, so yeah, there are various platforms, right? But usually, the if there is small company who has like a generic platform engineering tool team like we have, a skill set can be a cloud platform, right? You need to know one cloud platform. For example, AWS, GCP, or Azure. These are the major cloud providers. There can be others as well. But let's say a world where AWS, okay? You need to know AWS, all the basics of AWS. Then on top of AWS, there will be a compute platform. Now that can be EC2, that can be Kubernetes cluster, that can be serverless, right? On top of that, what there will be a operating system platform. So you need to know operating system, right? So most of the time it's Linux, but in some cases there will be Windows as well. You need to know that. Now on top of that there will be an applications, then depend on company, Golang, Rust, some sort of language, and some sort of infrastructure as a code kind of languages, which is Terraform or Crossplane or uh, Puppet or Ansible. So I think tool wise it's quite vast, again similar to SRE, but I think that's more verbose answer of it.
Yeah, that's pretty interesting. It looks like it's very similar to what SREs would look at, right? In terms of tooling, in terms of fundamentals. And that is necessarily not because platform engineering, or I would rather say platform engineering and SRE, all of this is trying to achieve the same thing, right? Which is developer productivity, agility, good time to market, and sanity for developers in the end, where and reliable services going out to customers. So it's very possible that you mix and match platform engineering, SRE. I saw some interesting talks on YouTube, which was like SRE is dead, long live platform engineering, and I'm like, yeah, sure, like whatever floats your boat, whatever helps you make your services more reliable for your customers, whatever fits your organization, you should do that. And as we said in the DevOps episode, DevOps is the end goal, or DevOps is like sort of the guiding philosophy, and your implementation may vary depending on what company you have and what tooling you have. I know a bunch of companies who are still working on bare metal systems and VMs. Their platform or their SRE structure will look different from your SRE structure if you're like a bleeding edge cloud native cloud first company, right? So do what's fitting your company best and use the tooling that's right for the job. But there's a lot of opportunities in this space, including SRE, platform engineering, DevOps, cloud application, cloud services. This space is growing quite rapidly, so this is some valuable skill sets that you can look into if you're trying to get into this domain. So thanks for that, Suraj. Final
I think
question. Go ahead.
just one more thing before we go further. I think you mentioned that there was an article SRE is dead, right? So I think nothing is dead. Everything keeps evolving. People did mention that sysadmin is dead because DevOps is there. Like, I still see there are positions which call themselves as a system administrator. People say DevOps is dead because SRE is there. There's still positions about DevOps. So I would say nothing is dead. It's just that whatever suits the requirement of particular company, they just go with it, and they keep evolving their philosophies. They keep evolving their methodologies. So nothing is dead.
Nothing is dead. Like we still have people writing Perl scripts in like whatever, right? Perl and like languages that I don't even know of.
I
So
think
they are
I
still
think
used in traditional mainframe systems. So
I think you're saying about the Pearl, but if you do some basic Google search, the highest paying jobs are not Golang, Rust, or any front end. It's COBOL and all those old languages, right?
yeah,
Because so does that mean if they are old, are they dead? No, right? Yeah,
yeah, they're just not like the latest cool thing. So that's one thing to urge the audience to think about is don't think of this as like going from tool to tool to tool. Like if you are the expert on one tool and like that has market demand, it has significant consumption, don't listen to all the people who are saying it's dead. You don't need to switch to the next big thing all the time. Sometimes it's okay to be an expert in one niche technology and just be that, right? Like you don't have to go from tool to tool or catch up on the next big thing. It's important to know and keep up with the trends, but like if you're working for a bank and like writing COBOL and having success out of it, more power to you, right? Because in the end it's very relative. What people are saying is based on their perspective and their context. It's important to keep an open mind about the new technologies and try to incorporate the latest developments, but in some cases it's just not possible, right? You don't want to take an entire bank and move it to Kubernetes in one day, right? That is a recipe for disaster. So you need to take
Yeah.
into consideration software lifecycle and organizational constraints and so on, as you go in this journey. So I see that mistake very often. It's like someone comes in and they're like, "Hey, why don't you move to Kubernetes right now? Like this entire setup is like very old, and like what are you doing?" And it's just you just have some constraints in the organization. Rohit is here. Let's take Rohit's question. Thanks for joining, Rohit. Do you think in the future cloud platforms related products, SRE and QE, would be a mixed and interchangeable role?
What do you think, Aditya? Before I answer.
Future cloud platforms related products, SRE and QE. I think SRE and QE still have their own place, right? So SRE and QE, while are focusing on the same thing, which is to deliver high quality and reliable services, they are not necessarily interchangeable, at least in my perspective, because SRE focuses on SLIs and SLOs and systems reliability. QE is sort of broader in a different angle. Like it also focuses on quality of the product, and quality for me is a very broad term where we say, is the product reliable is one part of quality, but is the product usable is also one part of quality. Is the product intuitive is also one part of quality. Is the like what are the kind of usability journeys that the user is looking at. So SRE and QE can learn a lot from each other, because QE can give SRE that feedback saying, here's what a quality product looks like, and SRE should then say, what are your metrics, right? How do you measure quality? Let me incorporate that into SLIs and SLOs. So that way what we can do is, if SRE and QE are both looking at the SLIs and SLOs together, then we can guarantee that the product is reliable as well as high quality, and we can measure it and we can track progress together. And that way these two teams can work together and champion the user experience in the end. Because what happens then is, if there's a user experience breaking change, that shows up as a metric on the SRE dashboard as well as the QE dashboard, and that way these two teams can then go with the product engineering team and then say, hey, let's try to make this better, and that just increases collaboration. So in the sense of DevOps, all of these teams need to absolutely work together to make a successful cloud product or service, but they are not necessarily interchangeable just because they are focusing on different things. As is SRE is focusing on slightly different things of the same problem, slightly different problem domain for the same service, as compared to the product engineering. Product engineering is focused on the business logic of the application. SRE is focused on the application, but the reliability of the application, which requires a different thinking set or mindset. That's my perspective. Suraj, would love to hear what you think about it.
I think like they cannot be mixed or they cannot be interchanged, but I think they'll always be, adjacent to each other. And definitely there will be knowledge sharing between these two, so that both the teams can, deliver their own things accordingly. So I think that's my opinion, very similar to yours. Yeah.
Yeah,
So
like
because the thing
there's
is
some
like,
specific. Go ahead.
no, go ahead, yeah.
I was just going to say there's some specific things I can think of, right? For example, chaos engineering has a very good overlap with SRE and QE, right? Both SRE and QE should care about chaos engineering, because SRE wants to make sure through chaos engineering that the product is reliable in terms of and resilient in case of failures or partitions or so on. And QE cares about it because a high quality product is reliable, right? A product is high quality if it is reliable. So that is one thing that you can work on together. But specifically on the differences, for example, SRE is not going to go into test coverage, right? SRE is not going to build automated tests for the product, right? That's just not part of the SRE um, domain. SRE is going to look at the architecture of the product and like distributing it, scalability, performance of the product, but not necessarily is the product does the product code have good functional test coverage, or like is there end to end tests that are covering user experience? That's a feedback loop. That's like a thing that we can consume to make sure that the product reliability is high in production, but that's not necessarily something that SRE is going to go develop, right? So we need someone to take care of it. And in a DevOps team, and I keep saying DevOps team because I think of a service team as one singular logical unit. There will be people who do product, who are focused on product development. There will be people who are focused on QE. There will be people who are focused on reliability, and that one team together comes together as a service team. That's my take on it. Rohit, would love to hear what you think about it. I know you have been working in this domain for quite some time, so would love to see your comments there.
Yeah, cool. And I think one more thing just to add here is, like you mentioned the chaos engineering, right? Now I'd like to add the, you know, platform engineering aspect of it here. Is like, for example, if we consider this domain of chaos engineering, now I, as a platform engineer, I will look after this chaos platform, right? For example, the very famous open source chaos engineering platform is the Litmus Chaos, right? So I'll look after deploying and managing and maintaining the Litmus Chaos platform. I'll maintain all the documentation of it. For example, if you want to, you know, define some sort of scenarios or some sort of things, I'll make sure that everything is there, right? Now you as a SRE will do some sort of, you know, chaos. You will use my platform to do chaos testing, and also QE will also do these kind of chaos testing. But you both are like user of my platform, right? You will use the same platform for different thing, and as a QE, Rohit will use the platform for different thing, right? The outcomes may be different, but you both are using leveraging the same platform. Yeah.
Yeah, and in the end, it's very helpful that we are standardizing some of these things, right? As we go towards more standardization, then we can talk about the same thing, and when we talk about the same thing, we have a multiplying impact, because then there's less silos, right? If we said every team creates their own chaos platform, and then like, or as we have had sometimes, every team uses their chat system, like their own chat system, their own CI system, and then I come to you and I'm like, hey, I need help with the CI, and you're like, no, I use a different CI completely. I have no clue what you're talking about. So just bringing these tools together as a platform, I think it's a very interesting idea. It totally depends on like how you manage to sell that platform. I think that's still an interesting challenge on adoption, right? For example, you go there and you say, here's my chaos testing tool, and someone goes, nope, I'm going to use something else. So how do you actually like build that bridge and say, hey, we actually need to use this because it's in the benefit, or it's in the interest of both of us if we use common tooling, right?
Yeah.
So do you have any examples of some success stories of like you working with the SRE team? And that's what I would perhaps like to close on. We are on time. So any like highlights, or what's the best story you have seen? What's the most successful collaboration you have had with multiple teams such as SRE and QE, where you built something and you got user feedback that, hey, this is fantastic, this is something that changed our lives?
Definitely. So, for example, being a platform engineer, again, we look after the Kubernetes platform, but SRE team, they made some tools around this, you know, SLOs and all these kind of thing, which automated few things for our users. So that collaboration was quite good, right? Like when we and SRE, we sat together and, like, you know, we developed some system which is now helping user to define their SLOs, for example. uh, another thing I can think of is having some sort of standard labels, right? Now SRE team came up with this thing called, let's say, a standardized label system across the infrastructure, right? Now the reason for that is various things, like, you know, if you want to see the cost of particular thing, you need to have particular set of labels or particular set of tags. Now SRE came up with this concept of having those things, whereas we as a platform engineer, we implemented those things in the platform, right? Like, I won't say we completely did it, we are working on it to do those things. Eventually we might open source these things as well. But yeah, these kind of collaborations goes together. Yeah. uh,
Absolutely. We
this
have
this
a pizza question before we close off, right? So Chaitanya has a question. Thanks for participating, Chaitanya. So the SREN platform team make the pizza base, and the product has to make the sauce, toppings, etc. And this is all. This is something that I always find interesting. Where's the separation, right? Who makes the base? Is the SRE team providing the pizza factory, or are you creating the pizza base as well? Like, what's the separation of concerns here? Like, how do you stop the SRE? How do you stop the platform team or the SRE team to from making the entire pizza? Right? You could say, hey,
so
here's a pizza, take a pizza and sell it.
so I would like to look at this problem little bit differently. I would say neither SRE, neither platform is making the pizza base or toppings. Developers are making pizza base, they are making the toppings, they are making everything. Okay. But as a platform or SRE, what we are doing is we are helping them with other things. We are putting the machine in the store, which will help them to make pizza. Okay. We thought, we got to know that these ovens are not good, we upgraded the ovens so that they can make pizza faster, right? So that's platform engineering, right? Now we put a display so that they can see what are the order numbers, next order, how many orders are in the queue, like how many orders we have done today, right? Or we provide the delivery persons who are fastly, they are just picking up the pizza fastly and like delivering it to customers. So we as a platform and SRE are all other things, whereas the person who is like literally making the pizza is a developer or a product team, I would say.
Yeah, we need to change this example, Suraj. This pizza example is making me too hungry. We need to make it like a salad example in the interest of health. But on that topic, what I would say is I completely agree with you. For the pizza example, what we do is the platform engineer in that case would provide the oven, right? Or provide the table on which you make pizza, provide the tooling that you can make the pizza with. But in the end, it's the developer's responsibility to make the pizza themselves, right? The SRE will then look at, hey, is the oven heating fast enough, right? Do we have enough pizzas per hour, or do we not have enough pizzas per hour? Like we talked about latency, does the customer get the pizza in 30 minutes? If not, why not, right? And then we can then, when I go back to the collaboration between SRE and platform, then we can give the platform team some feedback like, hey, the oven is not hot enough, you need to upgrade the oven, let's get us a better oven, or let's get a better service. Instead of delivering on cycles, let's deliver on bikes, right? So that is the job of SRE, is to look at the specific process of creation and delivery and look at the user experience and give feedback to the platform team in this case about what can be improved, and perhaps even work on finding the better oven, finding the better ingredients for the pizza, like where is your cheese coming from? Right, that's what SRE would focus on. It's like, how quickly does your cheese melt? Weird things, right? Weird things that do add up in the interest of user experience of the service. That's what SRE would then focus on.
Yeah, makes sense.
Quite an interesting problem statement. Anyway, Suraj, this was very helpful. We are on time, and I think this was a very good chat. We can expand on that if people are more have more interest in the specific topic, or any other topics that people have interest in. We are always open to trying out new topics. So if you have something in mind, people, please do comment in LinkedIn, YouTube, wherever you're watching this, and we will try to take that topic in one of the future videos with Chine Cloud. And Suraj, I'll hand it off to you to close this off.
Yeah, definitely. Thank you, Aditya, for being host today. Again, the recording of the sessions will be available on both uh, LinkedIn as well as YouTube. Do check out the links to contact us are in the description. Our DMs are quite open, so you can reach out to us if you have any questions and queries. uh, yeah, and that's more about it. And I think stay tuned for the next sessions. We haven't really decided what our next session will be, but yeah, because it's a casual, we'll just decide throughout the week and we'll let you know. But before that, if you have any suggestions, the session we should cover, if it is within our capability, we'll definitely do it. But again, thank you so much for joining. Thanks, Aditya. And I think, yeah, see you next Sunday. Bye.
Thanks, everyone. See you next time.